Hi, awesome pre-calc. So this is example 4 in 5.4. There's a lot of parts, so we're going to do it one at a time and do it slowly, okay? Example 4, A, find the domain. So we're going to do it one at a time. So A, domain, okay? And just like previous, domain is, the domain of all log function is going to be greater than 0. So what you do is you take this, okay? You set it equal to, to 0, you solve for x, you draw your number line, okay? It's not always obvious. Sometimes it is, but sometimes it isn't. Then you test to see which one will make it positive inside of the parentheses. So when I plug in positive 100 minus 2 is going to be positive. Negative 100 minus 2 is going to be negative. Now there's a negative in the front. That does not affect the domain. That is a reflection, okay, over the x-axis. That means it changes the y value, so I don't really care. So when it's asking for the domain, you only need to focus on what's inside of the parentheses, okay? Since it's positive from here to here, and I cannot include 2, the domain is 2, non-inclusive, to infinity, and we box that up. And again, sometimes it's obvious, so you don't have to draw a number line, but if it isn't, then please do draw a number line. B, it says graph F, okay? Graphing, even though you are not required to make the parent function anymore, I still do it, okay? So the parent is going to be y equal to natural log of x. And remember, natural log of x is going to be, this is the inverse. Inverse is e to the x equals y. Because sometimes I don't remember what 3 points I'm supposed to use. But if I understand the inverse, I can get the points for my log. When I plug in negative 1, I get e. Oops, I meant 1 over e. Because for me, exponential function is more natural to me, right? I can do exponent log, not all the time, okay? So when x is 0, e to the 0 is 1. When x is 1, e to the 1 is e. So now this is the inverse, but that's not what I want. The parent function is going to switch the points. That means I have 1 over e, comma, negative 1, 1 comma 0, and e comma 1. Then there is the next equation is y equals negative natural log of x. This is a reflection over the x-axis. That means y is changing. So if y is changing, all my y values are now negative. So 1 over e, negative 1 is now positive, okay? Well, the 0 is still going to be 0, and e comma negative 1. Then I have one more equation, y equals the negative, we already took care, ln of x minus 2. This is a translation to the right by 2. What does that mean? That means I'm going to add 2 to all my x value. Now, because I'm adding 2 to all my x values, x has e in it. I'm just going to leave e as e. Okay, so 1 over e plus 2 is now, it's like, think of it as this. 1/3 plus 2 is like 2 and 1/3. Same thing with e. 1 over e plus 2 is 2 and 1 over e. Okay, e it's about 2.718. So around it, okay, approximate it's about 1/3. So that's what we're going. So this is 2 and 1 over e comma 1. And then 1 plus 2 is now 3 at 0. And then I can't really do e, so I'm going to do 2 plus e is what 2 plus e is, okay? And e is about 2.7, so it's about 4.7. So that's where I'm going to have it. Now, as a parent, you used to have an asymptote at 0, okay? So keep in mind that it's going to change now. So let's plot the points first, and then we'll draw in the asymptote. So these are the points that you are required to have after all the transformations, okay? So 2, 1, and 1 over e is about 2 and 1/3. So 2 and 1/3 will go up 1. So anyway, in between there is fine. 3, say it's 0, okay? And then you have 2 plus e, so 2 plus 2.7, that's 4.7-ish, negative 1. 1, 2, 3, 4, 4.7, negative 1. Okay, so these right here. Now you need to have also what? The asymptote. Okay, remember the domain of the parent was supposed to be 0 and on, right? So positive real numbers. So the domain used to be at y equals to 0. We'll move it to the right by 2. So now you're going to have a y equals 2. And that's what you have to have for your asymptote. Then I'm just going to be hugging the asymptote. Okay. If you miss your dots, make it really big so that way it looks like that. So that is, okay, the graph of negative natural log of x minus 2. C, it says from the graph, determine the range and any asymptotes of f. Okay, so range, the range of logs is always all real. Asymptote, you're going to have a y equals to 2. Okay. D says find the inverse. Okay, so D, inverse means you're going to switch x and y for x, and then you're going to solve. So x equals negative natural log of y minus 2. To solve for it, make sure you isolate the natural log. So what that means is I'm going to divide both sides by negative 1 in the front. So this will leave me a negative 1x equals positive natural log of y minus 2. Now, you can't solve log, so make sure you rewrite it, okay, in exponential. So again, to solve for y, you rewrite it in exponential. So I'll spell it out. Rewrite as an expo. Okay, so what that means is I'm going to write e to the negative 1x, which is the same as negative x, equals y minus 2. And you're going to solve normally. I'm going to add 2 to both sides. Okay, and so this is going to be y equals e to the negative x plus 2. This is an x. Okay, now what if you write it like this? Y equals e to the negative x plus 2. As a teacher, I would totally mark this wrong. Okay, this is incorrect because remember this 2 right here, I want to make this point really clear. It should, ooh, that's so fat. This 2 right here should totally line up with your y value. Okay, if you make it so where it's an exponent, I will, and I'm gonna say this clearly, okay, I will mark it wrong. The 2 belongs as lining up with the y and the e. Okay, the 2 is not an exponent. So my inverse function is, here we go, f inverse of x is e to the negative x, e to the negative x, and then we have add 2. Make sure I line that up. Okay, box that up because there's a lot of work involved. I don't want my teacher to be confused. Okay, next, what was the next one? E, find the domain in range of f. Okay, so E, I'm gonna put it, how about E right here? Domain, is it f or f inverse? F inverse, I'm sorry. Domain of f inverse, range of f inverse. Now this is quite easy because if I know the domain and range of f, I can find the domain and range of f inverse. Okay, so the domain of f inverse is the range of the regular, and the range of regular is right here. Okay, so the range of regular is now the domain of inverse. And I'm gonna go look for the other one. It says the range of f inverse. That means I'm now going to find the domain, okay, which is right here. Oops, I did not mean to do that. Oopsie. Okay, the domain is right there. So I'm gonna write that in my range of f inverse from 2 to infinity. Okay, so that's that. What's next? All right, we got E done. Okay, F, graph F inverse. Okay, well, graphing F inverse is quite cool because I don't have to do any work. Okay, so I'm gonna put F right here. All I do is switch points from F. You're right. So F was 2 and 1 over e comma 1. So now I have 1 comma 2 and 1 over e. Voila, right? And then 0 comma 3 and negative 1 and 2 plus e. I used to have an asymptote, y equals 2. Now I should have an asymptote of x equals 2. Okay, so here we go. X equals 2. I wrote y equals, but that should have been x. Shoot. Totally messed this up. Okay, this is x. Whoa. Sorry about that, class. Okay. So x equals 2. Wow. That was, I want to make sure asymptotes. Fix this one as well. I apologize. That was horrible. Okay. So x equals 2. And I think that's all that is. Okay. Now, that means y equals 2. I switched my x and y. Totally wrong. Okay. It's a silly mistake, but it's a huge concept. Okay. So this is now x equals. Oh, see? Look at that. My brain is totally switched today. Okay. So y equals 2 is my new asymptote. Then I'm going to plot my points. 1 and 2 and 1 over e. That's about 1 and 2 and a third. So 1, 2/3 about right there. 0, go up 3. Okay. And then negative 1, 2 plus e, so 2.2.7, that's just 4.7. So negative 1 and 4.7. 1, 2, 3, 4, 4.7. I'm going to cautiously draw this. If you miss any of your dots, just make your dots bigger. So here's my F inverse, okay? And let's double check to see if they, oops, add this extra arrow up here. Oh. Well, I guess it's not supposed to be there. Okay. So if I were to draw the line, okay, x equals to y and y equals to x, these two curves, okay, should line up with one another. Not line up, I meant reflect over that line perfectly. Okay. So that's how we do all of them put together. Let's try one more, okay, and then we'll call it a day for this video. Three log of x minus 1. So part 1 says find the domain. So we are going to find the domain. Let's make it bigger so you can see. I'm going to take x minus 1 and I'm going to set equal to 0. Solve for x. I'm going to have x at 0 at 1. Draw a number line. Okay. I can't have that, but I can totally have whatever's positive. So when I plug in negative 100, it's going to be negative. When I plug in positive 100 minus 1 is positive. So my domain is from here on. So what that means is going to be from 1 to infinity. And again, sometimes it's really obvious. Like this one is going to be really obvious. So some of you might not need to draw the number line. Okay, but when it gets difficult, then you're going to need to. Part B says graph it out. So here we go. I'm going to start with the parent, even though I don't make you do it in stages anymore, but it's a good idea to have it. Okay, so this is log, and notice how you don't see a base at all. If you don't see a base at all, this is base 10. So what does that mean? This has an inverse function, okay, of 10 to the x equals y. I can find my inverse point easily, and if I know my inverse, then I can totally find my log, okay? When x is 1, 10 to the 1 is 10. When x is negative 1, it's going to be 1/10. When x is 0, it's going to be 1. So if I have that, then I know my parent is going to be switched 10, comma 1, 1/10, comma, negative 1, and then 1, comma, 0, okay? Then the next one, I'm going to do 3 log of x. This is a vertical stretch by 3. That means y will multiply by 3. So my new 3 points are 10, comma 3, 1/10, comma negative 3, and 1, comma 0. Next is going to be y equals 3 times log of x minus 1. This is to the right by 1. That means x is going to add 1. And y stays exactly the same as earlier. So here are my 3 points. Okay. All right. 10 plus 1 is 11. Y stays the same. Okay. 1 over 10 plus 1 is now 1 and 1/10, comma negative 3. And 1 plus 1 is 2, 2, comma 0. Now, normally you do have an asymptote, okay, at x equals to 0, but because I'm going to the right, now I have an asymptote at x equals to 1, okay? All right, plot the dots. This is a 10 by 10 grid, so 11 means I'm just going to go a little bit to the right, up 3. And then 1 and 1/10. Oh my, that's tiny. Negative 3. And then 2 is going to be at 0. So what's happening is I am vertically stretching it. So that's why this looks, oh, I missed a dot. There you go, make it fat. Okay, so that's what the graph is supposed to look like. All right, part C, what was it asking? Range and asymptote. Okay, so part C, the range, it's always all reals in log. Okay, asymptote is going to be x equals to 1. Next one, what is D asking? D asking inverse. All right, let's find the inverse. D inverse. That means you're going to switch x and y for x, and then you solve, okay? Inverse. All right, switch. Here we go. X equals 3 times log of y minus 1. Okay, so first I'm going to divide both sides by 3. You want to isolate your log, so what you have now is x over 3 equals log of y minus 1. Okay, so would it be correct, okay, to do this? Add 1 to both sides. And if you're not listening to me right now, you're probably writing this down, okay? And if you're writing this down, know that you're doing something completely wrong. Okay, so class, please don't do this. I would totally cry. So this is not okay to do, just so you know. Again, this is not okay to do, okay? So you cannot take things out of the parentheses if the log is not what? Gone. Okay, so to get rid of log, you rewrite it as an exponent. Okay, so this is log base 10. So what does that mean? You're going to write 10 to the power x divided by 3 equals y minus 1. Now the log is gone. You can add 1 to both sides. So you can end up with y equals 10 to the x divided by 3. That is an exponent plus 1. And this is right here your final answer as an inverse. So we're going to write it as an inverse and we'll box it up. So f inverse of x is 10 to, you can even write 1/3 x, that's the same thing, plus 1. And we are going to box this baby up. Part D, inverse is done. Part E says find the domain and range of inverse. Okay. Part E says domain of f inverse and range of f inverse. Okay. So what that means is that to find the domain and range of f inverse, I just have to go look at the regular function. So the range of the regular function is all real. That means the domains, it's all reals. The domain of the inverse was 1 to infinity. That means the domain of regular is 1 to infinity. That means the range of an inverse is 1 to infinity. Okay. Part F, you are graphing out. Graphing out is beautiful because all I have to do is go find the point of my original. Ready? The original points are 11, 3. So now my inverse point is 3, 11. Okay, and switching my x and y. And here are the 3 points. It used to have an x equals to 1, so now I have a y equals to 1. Okay, so 3, 11. So I'm just gonna go up above my box a little bit. -3 and 1 and 1/10. 0, 2. So here it is. Here's an exponential curve, which looks familiar because we did this a lot before. Okay, so there it is. So that is the whole thing. Okay, this is the end of this recording.